Our second lesson for today is going to be solving radical equations. Radical just means it's going to have some sort of root in it. Square root, cube root are the two most common. And equations means now we're going to have an equal sign. So we've got 4 steps to solve a radical equation that has one square root. So first step is to isolate the radical on one side of the equation. So that means if there's anything out front of it, underneath it, or behind it, not in the square root or cube root, then we want to get rid of it by moving it, add, subtract, multiply, or divide. Then we're going to square both sides. Squaring a square root is an inverse operation, like adding to and subtracting to. They cancel each other out. So squaring and square rooting are those inverse operations to get rid of it. Then we're just going to solve for our variable. If we get more than one answer, we've got to check the solutions to make sure that one of them's not extraneous. It does happen. So looking at the first example, if I go to step 1, we want to isolate the radical on one side of our equation. So when I look at the radical here, the radical stops right there. So we've got to get rid of this -5 to isolate it. So I'm going to get rid of that -5 by adding 5 to both sides. That gives me the square root of x plus 3 equals 5. So step 1's done. There's nothing out front, underneath, or now behind my square root. So that's how I know step 1 is complete. Step 2 says to square both sides of the equation. So I'm going to square the entire left side and the entire right side. I know that I'm squaring because I've got a square root. So squaring my square root cancels both of those out, so it leaves me with x plus 3 on the left. On the right side, we have 5 squared. Well, 5 squared is just 25. So that completes step 2. Step 3, we want to solve for the variable. I want to get the variable or the letter by itself. Currently, we have x plus 3. I want to get rid of the 3, so subtract 3 from both sides to get x equals 22. And since we only got one answer, we don't have to worry so much about checking the solutions because we only got one answer. So it's going to work if you only get one. Let's look at question number 2. Step 1 for question number 2, we want to isolate our radical. We've got to get rid of anything out front, underneath, or behind. Again, if it's behind, it can't be in the square root. My square root ends right here. So there's nothing out at the end, there's nothing underneath, but there is this 1 sitting out front. So to move that 1 is being added to our square root, so we want to subtract it. So now we have the square root of 2x plus 3 equals 5. Now I've isolated my radical. I'm going to move to step 2. Step 2 says square both sides of our equation. So we're going to take the entire left side and square it, the entire right side and square it. When I square the entire left side, the squared and the square root cancel each other out, leaving you with 2x plus 3. And the right side, 5 squared is 25. They won't all be 5 squareds, I promise. These two just happen to be. At this point, I'm moving to step number 3. We want to solve for the variable just like you would in algebra 1. So subtract 3 from both sides, 2x equals 22. Beside it, divide both sides by 2 to get an answer of x equals 11. Questions on these first 2? So hopefully fairly simple once you get down the steps. All right, next 2. Question 3, first step, I want to isolate the radical. This time the radical's on the right side. That's okay. We're still checking in front of it, underneath, and behind it. In this case, there's nothing in front, underneath, or behind it, so step 1 is done. Step 2, I've got to square both sides. In this case, the right side's the easy side because the squared and the square root cancel, leaving you with x plus 10. The left side is the one that tends to trick students. So if I have x plus 4 squared, that means I'm going to take x plus 4 times itself, x plus 4. Tendency is that people will just take x and square it, 4 and square it. It's not the same thing. So I'm going to take x plus 4 times x plus 4. That's really just a box problem. You can FOIL it out if you want, same thing. So I'm going to take x plus 4. I know there are students who can do these in their heads. That's fine. We're just going to write it. So x plus 4 times x plus 4. X times x is x squared. 4 times x is 4x. X times 4 is 4x. And 4 times 4 is 16. So when I combine like terms, I have like terms here. So x squared plus 8x plus 16 is actually what x plus 4 times x plus 4 is. So now I have this new equation, x squared plus 8x plus 16 equals the x plus 10. We're going to move everything to one side. Because we have an x squared, anytime I have x squared, I automatically think x asterisk. So I'm going to subtract 10 and subtract x from both sides. So x squared plus 7x plus 6 equals 0. So now that I have 0 on one side, this is what I'm going to put into my asterisks. So A goes top left, top right. That's 1 and 1. This is 1x squared. B goes in the bottom middle, so 7 goes in the bottom middle. And then your top middle is 1 times 6, which is just 6. So two numbers that multiply to give me 6, but add to give me 7, 6 and 1. Looking at my two fractions, neither one of them are reduced, so I have factors of x plus 6 and x plus 1. Remember, x and 1x are exactly the same, so I could write either. Once I get here, I'm going to set both my factors equal to 0. So if x plus 6 equals 0, I get an x value of -6. If x plus 1 equals 0, I get an x value of -1. In this scenario, we get 2 answers. If you get 2 answers, you must check them because it's likely that one of them is extraneous. Not always, but sometimes. I believe there's one on your assignment that both of them work. Or maybe I dreamt that. I don't know. So when we check them, you're going to check one at a time, going back to the original equation. So -6 plus 4 equals the square root of -6 plus 10. So again, going all the way back to the original, nothing that I've modified or changed. So then I'm just going to simplify this. I'm going to simplify the left side independently of the right side. So -2, when I combine those, equals, well, -6 plus 10 is 4. I know the square root of 4 is 2. Is 2 equal to -2? My left side does not equal my right side. So if they don't equal, we normally just put a slash through the equal sign. That means that this answer is extraneous. Extraneous means we didn't do anything mathematically wrong. We just got an answer that didn't work. So it's extra. Hopefully the second one works. So if I plug in -1, I'm going to have -1 plus 4 equals the square root of -1 plus 10. Let's see, that's 3 equals the square root of 9. Well, Square root of 9 is 3. 3 equals 3, so that one works. So go back up. This is your answer. So sometimes in the past, I've had students try to tell me that this down here is their answer. That's not your answer. That's when you checked your answer to make sure that it worked. So -1 is our only answer, even though we didn't do anything wrong and mathematically we got 2 answers. Let's try question 4. For question 4, the first step, we want to isolate the radical. So we've got to move this 4 out front by subtracting 4 from both sides. So now we have the square root of x plus 2 equals x minus 4. So step 1's done. There's nothing in front, underneath, or hanging out at the end of my radical because it stops right after the 2. Then I want to square both sides, keeping in mind we're squaring the entire left side and the entire right side. When I square the entire left side, the square root of x plus 2, when I square it, the square root cancels, so just x plus 2. And then the right side really means I have x minus 4 times x minus 4. I'm going to cheat and go back to this box over here. Oh, maybe not. I thought I would. So x squared minus 4x plus 16. So when I combine like terms, I'm going to have x squared minus 8x plus 16. At this point, again, I have the x squared, so I'm going to move everything to one side, knowing that I need to use my asterisks. So 0 equals x squared minus 9x plus 14. Fill out our asterisks. We have 1 top left, top right, -9 in the bottom middle, and 1 times 14. Ooh, that didn't. In the top middle, which is just 14. So 2 numbers that multiply to give me 14, but add to give me -9, -7, and -2. When I look at my 2 fractions on the sides, I have 1 divided by -7, which doesn't reduce, so I'm going to add my x up there to the top to give me the factor, x minus 7. My other factor over on the right side is going to be x minus 2. If I set both of these equal to 0, I get answers of x equals 7 and x equals 2. Since we ended up with 2 answers, we must go back and check them both. So I'm going to check the 7 first. Remember, you're going all the way back to the original. So 4 plus the square root of 7 plus 2 equals, 4. Not 4, 7. No. So in the original, I've taken both of those x's out. I've replaced them with 7. Then I'm just going to simplify. So 4 plus square root of 7 plus 2 is 9. Well, the square root of 9 is 3. Is 4 plus 3 7? Yeah. So 7 equals 7. This one works. So I know that this is going to be an answer. Then I'm going to check x equals 2. So 4 plus the square root of 2 plus 2 equals 2. So 2 plus 2 underneath my square root gives me 4. We know the square root of 4 is 2. Is 4 plus 2 equal to 2? No. So 6 does not equal 2, which just means that x equals 2 is extraneous. Questions on this one? My favorite one's next. I'm serious. See, do my notes. So the next one is indeed easy. So we can't really do step 1 because we've got 2 square roots. So we've got a square root on the left side, a square root on the right side. Technically, they're both isolated on their own sides. So we get to skip to step 2, and this is why it's my favorite. So we're skipping step 1, and we're going to square both sides. What's going to happen when I square both sides? So both square roots are going to cancel with the squares. That really just gets rid of my square roots and leaves me with 9 minus n equals 16 minus 2n. Do I have any n squareds? No, I don't have a quadratic anymore, so I just have a basic algebraic equation that I need to solve for n. So I would add 2n to both sides. So 9 plus n equals 16. Subtract 9 to get n equals 7. Do I need to bother checking it? No, I got one answer. You can check it, but it does work out. That's why this one's my favorite. So both square roots canceled. There was no asterisks involved, no factoring, one answer. I didn't have to check it. Lots of reasons why it's my favorite. So on the next page, you are doing, I believe, the odds, the whole left side. The ones on the front, you get one answer. Actually, you get one answer for question 7 on the back too. When you get to questions 9 and 11, you will get 2 answers. For both of those, make sure you check both of them. Don't check one and assume that the other one either works or doesn't work based off the answer that you got for the other one. So don't try to be lazy.